Hi everyone, this is Mr. Hall and this is a really quick video about Earth's resources. This is like the first sort of part of the final unit for AQA GCSE, which is quite a fluffy unit, but it's got some important chemistry you have to know. It might also be sort of similar to what you find in other specs, but it's mainly for AQA. So in today's video, we're going to cover a few things which you need to know about this topic. It's like an introduction really to the whole unit. And they're as follows. So you're going to state the 4 things that humans use Earth's resources for. You'll be able to recall what natural and synthetic resources provide us with. You'll be able to state examples of natural products that are supplemented or replaced by agriculture and synthetic products, and also distinguish between finite and renewable resources given appropriate information. There's also a few definitions you have to know within this as well. So first off, it's worth thinking about Earth's resources in terms of what man has always required. Now, we use Earth's resources, and we've always used Earth's resources to provide us with warmth, shelter, food and transport. And hopefully the images give you an idea of how we've used Earth's resources for these 4 different things. So in terms of warmth, obviously we can use timber from around us and then burn that in order to provide us with warmth. We've done that since the dawn of time. Shelter, whether it's in like caves or using natural resources around us to build huts, we've always done that. Food, whether it's crops like hunter-gatherers or whether it's hunting for animals, we have to do that to get food. And also transport, and sort of the crudest example I found is sort of rolling stones over if you're going to kind of build like a monument like Stonehenge. And obviously as time has gone on, we've been more sophisticated with that, which I'll come back to in a moment. So we've used Earth's resources to address all of these different needs. Now, these natural resources can provide us with a number of things to help us meet these needs. So whether it's timber, and that timber can be used for transport or for warmth, whether it's for food, which obviously is the same as that, whether it's for clothing and also for fuels. And fuels is a critical one in our sort of modern era. Now, agriculture is something that can help us use these resources that nature provides us more efficiently. And there's a couple of good examples of this. If we think about, there's 2 good examples here of food, basically. So back in sort of the dawn of time, we were primarily hunter-gatherers. Okay, we'd look for food, whether it's kind of animals or crops, and we would use that, and then we move on to another place where we'd find more of those things. We didn't really settle down. Now, with the advent of agriculture, we're able to settle and then grow crops and sort of try as best we could to control nature, and that meant we could feed more people, which led to a population increase as well. So agriculture has helped us with our food production and distribution. And another good example of how this has developed even more in the modern era is the role of chemistry. Now, chemistry has helped us make these agricultural processes and a lot of industrial processes are far more efficient, and that means that we can meet the needs for more people. Now, there's a couple of examples I'd like to kind of discuss here. One of them is around rubber. Now, rubber for a long time was extracted from a tree. It came from the sap of a tree. So what you do is, it's not too dissimilar to what you can see in the picture over here, where you sort of make a cut in the tree and then the rubber sort of pours down, you collect it, and that rubber can be used to make lots of different products. Now, in modern era, we have sort of replaced that with a synthetic version of rubber, and that synthetic version is produced from crude oil. All right, so you can do fractional distillation, and then you can do some polymerization, which hopefully you've learned in a previous unit, and that can help produce rubber. Now, both rubbers are fine. What we've found is that crude oil made rubber is now accounting for the majority of the rubber that you find in the market. Now, the problem is that this crude oil won't last forever. It's finite, so that's something which I'll talk about more later on. Another good example of how chemistry has helped us improve agriculture and industrial processes is in transport. Now, the example I'd like to talk about is the English Channel, and basically about seafaring in general. Now, in the dawn of times of early man, we were using very kind of crudely constructed boats, probably made out of timber with some twine and so forth. And they were fine, but you can't carry many people over them, and not very technologically advanced. Over time, we've obviously got a lot more sophisticated. So to cross the channel, you could take ferries, but you could also take the Channel Tunnel. Now, if you think about it, to make this happen is obviously a huge engineering feat, but it also required a lot of chemistry. Whether it's the chemistry required to make the body parts out of metal, again, that required some sort of sophisticated chemistry, and also the fuel, which is required to actually get the train moving. So chemistry has helped us to shape all of these processes that we sort of almost take for granted today. Now, the issue is that a lot of the energy and the materials that we get from the Earth particularly with the chemical sort of developments, are finite, and that's where you need to have a good understanding of definitions. Now, finite basically means a resource that is being used up faster than it can be replaced. Now, a good example is fossil fuels. Now, fossil fuels are coal, oil, and gas. We use them for a number of processes. They're running out, and I think at the moment, due to sort of current estimates, we're looking at around 2060. They will all run out if our rate of consumption does not change. Okay. Now the point here is that we're using them relatively quickly. Now, in theory, you could remake fossil fuels, but it will take millions and millions of years, and certainly the rate at which we use them, they're going to be run out way before they start forming again. So they're considered to be finite. Now, there are other finite resources, and it's important because when you think about finite resources, you would instantly think of fossil fuels as the natural example, coal, oil, and gas. But there's loads of other resources which are in danger of running out. Now, these are sort of cited from lots of studies which I've looked at, but one is fresh water. Now, fresh water, according to a lot of data, half the world's population may struggle to get their freshwater reserves by 2030, which is quite a worry. And then phosphorus is another important for fertilizers and growing crops. Now, we've got about 50 to 100 years left on the planet of sort of ready-made sources of phosphorus. Metals. Now, metals are something which are running out in terms of the way in which we consume them and how we dispose of them. Zinc and lead are sort of projected to be pretty much depleted by 2030 unless we change our practices. Silver and iridium by 2035, copper by 2050, and then a few rare metals depleted by 2090. So you can see that there is a finite amount of all these resources we have on Earth based on our current usage, and that's the key thing. The figures I've cited here, they depend on the rate of how we use them in future, and indeed how we reuse them, and our knowledge of current deposits. So, for example, with fossil fuels, we might find that there's new deposits somewhere on Earth which might extend the amount that we actually have recorded down. So there's lots of finite resources. Now, the key is that in order for humanity to sort of continue and survive, we need to use these resources sustainably. And that's where your definition of sustainability comes in. Now, sustainability is defined as being meeting the needs of the current generation without compromising the needs of future generations. i.e., if we're going to be using fossil fuels now, we need to use it in such a way that we've got enough fuel resources for the generations that will follow us, our children's, our children's children, etc. Now, that definition you have to know for AQA. You do have to know it. Now, there are many ways of using resources sustainably, and this is just one example. We could use renewable resources. Now, a renewable resource is a resource that is used up at the same rate as it's replaced, or the replacing is happening quicker than the rate at which it's being used. And what that does, it helps conserve those finite resources, and it helps improve sustainability as well. Now, an example I like to discuss, just to kind of flesh this out a bit more, is making polymers. Now, what you can do with polymers is that you can make them from ethene, which is extracted from crude oil via fractional distillation and cracking. Now, as we mentioned before, this is a finite resource. So if we continue, just write finite there, if we continue to make polymers this particular way, it's fine, it's just going to run out quite quickly, so it's not sustainable. Now, another way of doing it is making it from ethanol, which can be made by fermentation, which is basically, get some sugar and yeast and so forth. Now, that is a sustainable process. You can do that again and again. So we could do that process now without compromising the needs of the generations in the future, i.e. our children and our children's children. So that would be a sustainable approach. Now, questions that you're likely to get around this, because a lot of it might just be definitions like define sustainability, define finite, and match up boxes, stuff like that. You might also get a lot of questions around data where you're going to have to be asked to analyze data and then kind of explain it. And this is one example. So here what we've got is production and also recycling of plastic. Now, these are just four typical questions which you might be asked, and you might have to string it together into a much larger answer. So the first question, I might actually change the colour of my pen here to red so you can see it easier. There we go. Right, so the first bit is, what mass of plastic was produced in 1990? So we get to 1990, we'll look up here, and it's there. Now, you'll notice that that point is between these two lines, which is 15 and 16. So the answer for that would be 15.5. The one thing I would say when you're looking at graphs, and this is not just for this unit but for loads of units, be really precise. The examiner will give you a half block of tolerance. Okay, so for example, if you said 15 or 16, you would get away with it. Anything more than that, you'd lose the mark. So be really careful when reading off graphs. Always annotate it. I don't know why more students don't do that. Then how much of this was recycled? So if we look at this again, we go to this part of the line. Now this is roughly sort of 2/3 of the way up between 0 and 1. So I'm going to write maybe 0.67 in terms, and that's million tons. I'll put MT there. Been a bit lazy, but that's basically what it is. Okay, so in 1990, that much was recycled. How much of this plastic ended up as waste? Now, if you think logically, if it's not being recycled, it's going to be thrown away. So the way to get that answer is you've got your 15.5, and you take away from that the 0.67, and that gives you your answer. And then finally, why do you think recycle has increased over time? Now, this is where you have to bring your own knowledge to the fore here. Now, we know that recycling must happen of plastic because it's a finite resource, okay? And so you could say because it's finite and it's in order to make the whole process more sustainable. And then from there, you can talk about the way in which you're trying to meet the needs of the current generation without compromising the needs of the future generation. And that would be quite a nice, complete answer. So that's it. So I hope that's been a useful introduction to Earth's resources, and later on we'll talk more about potable water and the metals and so forth.